Last two examples here in section 7.1, sequences. So we want to find term a sub 13 in the arithmetic sequence where a sub 10 is negative 14 and a sub 30 is negative 54. So the 10th term is negative 14 and the 30th term is negative 54. That means in 20 numbers, so from 10 to 30, 20 numbers, the value has jumped down a value of 40, right? Again, I can set this up as points, x, y values, use my slope formula with y minus y over x minus x. It really is just applying to my term values and the number of terms in my sequence. Overall, it's jumped negative 40 in 20 numbers. That's a total of negative 2 per number. So that's a common difference of negative 2. So here's our little formula with our negative 2 plugged in here and minus 1 here. A sub 1 is what we're trying to find. And we are going to have to use one of these 2 points here to help us find this value. So let's pick one, either 10 or 30, doesn't matter, you choose. So if we do the 10, I guess I'm choosing because you're not here to tell me what you want. If we choose 10, then that means that a sub 10 is negative 14. So I'm going to put negative 14 in place of a sub n. I still don't know what a sub 1 is. I'm going to plug 10 in for n. Right? So we have 10 minus 1 is 9, and 9 times negative 2 is negative 18. So I have negative 14 equals a sub 1 plus negative 18 from this part here. So if I add the 18 to both sides, I will get a sub 1 equals 18 plus negative 14 is 4. So a sub 1 is 4. Okay, how does this help us? Well, now we have a formula. So we know that a sub n is equal to 4 plus negative 2n plus 2. So basically it starts at 4 and it's going down 2 each time. So our formula has to start at 6 to compensate for that. Alright, so like if we plug in a 1, we get 6 minus 2 is 4, and the starting term is 4. So now we want to find the 13th term. So to find the 13th term, we plug in 13. 6 minus 2 times 13, so 6 minus 26. So that's a negative 20. So the 13th term will be negative 20 down on its way to between negative 14 and negative 54. Okay, example 10 here is a geometric sequence. The 5th term is 4/5, so that's a sub 5. Its common ratio is 2/3, so that's r. We want to find the first term and the formula. Okay, so let's start with our generic formula. A sub n equals a sub 1 times r to the n minus 1 power. We don't know a sub 1, we have to solve for that. So we're going to have to use this right here and this, plug those in to help us solve. So the 5th term is 4/5. We don't know a sub 1. The ratio is 2/3, and that's going to be to the 5 minus 1 power because 4/5 is the 5th term. So that gives us 4/5 equals a sub 1 times 2/3 to the 4th power, right? So that would mean that a sub 1 is equal to 4/5 divided by 2/3 to the 4th power, which means 4/5 could be multiplied by 3/2 to the 4th power. Because when I divide by a fraction, I can flip it over and multiply it instead. So this would be 4 times 3 times 3 is 9 times 3 is 27 times 3 is 81. And then that would be over 5 times 2 times 2 is 4 times 2 is 8 times 2 is 16. So then we can simplify because 4 goes into 16 4 times. So that would take us to 81 over 20. So that should be the first term, a sub 1, right? So that means that our formula would be a sub n equals the first term, 81/20 times 2/3 to the n minus 1 power. If we're not sure we have the right answer, we can always plug one of the things in that we already know. So like we could plug 5 in and make sure we actually get 4/5. So a sub 5, 4/5 would be equal to 81/20 times 2/3 to the n minus 1, so to the 4th power. Well, let's see, 2 to the 4th power. So 2 times 2 is 4 times 2 is 8 times 2 is 16. So that would be 81 times 16 over 20 times, so 3 times 3 is 9, times 3 is 27, times 3 is 81. Look, the 81s cancel out. 16/20 reduces to 4/5. Sure enough, I got the number I was supposed to get when I plugged in a 5. So this should be the correct formula, and the first term is 81/20.